September 1944, Kummersdorf Proving Ground, 40 kilometers south of Berlin. A single rifle lay on the examination table under harsh electric lights. Around it, a team of German weapons engineers stood in unusual silence. They had spent the morning firing this captured American rifle at the test range, and what they had witnessed contradicted everything they understood about infantry firepower. The weapon before them was an M1 Garand, standard issue to every American infantryman. In the next 6 hours, these engineers would document performance characteristics that would fundamentally challenge German small arms doctrine and reveal a philosophy of weapons design they had never considered possible. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you. The M1 Garand had arrived at Kummersdorf 3 days earlier, one of several captured from American positions during fighting in France. Unlike many battlefield recoveries, this particular rifle was in excellent condition, showing only minor wear from field use. The weapon had been found in a foxhole near Saint-Lô alongside its fallen owner, accompanied by 12 8-round clips of 30-06 ammunition. The rifle's serial number, 3247819, placed its manufacture at Springfield Armory sometime in 1943. German intelligence officers had been collecting American small arms since the North African campaign, but priorities had focused on heavier weapons like machine guns, mortars, and anti-tank rifles. Individual infantry rifles received less attention. The assumption, built on decades of weapons development experience, was that all major powers had reached roughly equivalent solutions to the basic problem of equipping infantry with shoulder-fired weapons. This assumption was about to be systematically dismantled. Hauptmann Friedrich Weber directed the evaluation team at Kummersdorf. A career ordnance officer with engineering training from Technical University of Berlin, Weber had overseen testing of captured Soviet, British, and now American weapons throughout the war. His reports were known for their technical precision and absence of ideological bias. Weber approached weapons evaluation as pure engineering analysis, measuring performance against objective standards without regard to national origin. This professional detachment would make his conclusions about the M1 Garand particularly significant. When Weber and his team first examined the Garand, their initial impression was dismissal bordering on contempt. The rifle appeared crude compared to German weapons. The walnut stock showed machine marks and lacked the hand-fitted precision of a Mauser 98K. The metal surfaces were finished adequately, but without the polish expected on military small arms. Tool marks were visible inside the receiver. The overall impression was of a weapon manufactured quickly with minimal hand finishing. This was precisely accurate, but the Germans initially interpreted it as evidence of inferior craftsmanship rather than deliberate design philosophy. The technical specifications seemed unremarkable. The M1 Garand measured 43.6 inches overall length, weighed 9.5 pounds empty, and fired the standard American 30-06 Springfield cartridge, a rimless bottlenecked rifle round comparable in power to the German 7.92 by 57 mm Mauser round. The barrel length was 24 inches, producing muzzle velocity of approximately 2,800 feet per second with standard ball ammunition. These figures were entirely conventional. Nothing in the basic specifications suggested revolutionary performance. What distinguished the Garand from every other standard infantry rifle in service with any army in 1944 was its operating system. The weapon was semi-automatic, firing one round with each trigger pull and automatically loading the next round from an internal magazine without requiring manual operation of a bolt. This was not new technology in principle. Semi-automatic rifles had existed for decades. The German Gewehr 41 and Gewehr 43 were semi-automatic rifles in limited service with Wehrmacht units. The Soviet SVT-40 had been issued in substantial numbers. Semi-automatic operation offered obvious advantages in rate of fire and reduced training time for recruits. The critical question was reliability. Semi-automatic rifles were mechanically complex, with dozens of moving parts that had to function under combat conditions. Mud, sand, water, extreme cold, and inadequate maintenance could disable the mechanisms. Manual bolt-action rifles like the Mauser 98K were nearly indestructible, functioning reliably under conditions that would jam any semi-automatic. The German evaluation of the Gewehr 41 had documented numerous reliability problems. The weapon jammed frequently, was difficult to clean in field conditions, and required careful maintenance to remain operational. The Gewehr 43, introduced in 1943 as an improved design, was better but still problematic. Reliability issues combined with production complexity meant that semi-automatic rifles remained supplementary weapons in German service, issued selectively rather than as standard infantry arms. The Wehrmacht's basic infantry rifle remained the Karabiner 98K, a bolt-action design derived from the Mauser 98 developed before World War I. This was not technological conservatism but practical recognition that reliability and ease of manufacture outweighed the theoretical advantages of semi-automatic operation, when those advantages came with mechanical complexity and production difficulty. The Soviet experience with the SVT-40 had been similar. The rifle was well designed and functioned effectively when properly maintained, but combat conditions and the training level of average Soviet infantry meant that reliability problems were common. By 1942, the Soviets were phasing out the SVT 40 inches favor of submachine guns for close combat and retaining bolt-action rifles for longer ranges. The pattern was consistent across multiple armies. Semi-automatic rifles were desirable in theory but problematic in practice. Against this background, the American decision to adopt a semi-automatic rifle as standard issue for all infantry seemed either remarkably bold or foolishly optimistic. The Germans assumed the latter. Surely the Americans would discover what others had learned, that the mechanical complexity and maintenance requirements of semi-automatic operation were incompatible with the realities of infantry combat. The testing at Kummersdorf was expected to confirm this assessment. Weber's team would document the Garand's rate of fire advantage, note its inevitable reliability problems, and conclude that the Americans had made a typical error of prioritizing theoretical performance over practical durability. The first morning of testing began with basic function checks. Weber personally performed the initial inspection, field stripping the rifle to examine internal components. The disassembly process was straightforward, requiring no tools. Pulling back the operating rod handle and pressing the trigger allowed the trigger group to be removed as a single unit. The bolt and operating rod assembly then lifted out of the receiver. The entire process took perhaps 30 seconds. Reassembly was equally simple. This ease of maintenance was noted with approval. German weapons typically required more complex disassembly procedures. The internal components showed the same characteristics as the exterior, adequate machining without unnecessary refinement. The gas piston was a simple steel rod. The bolt was sturdy but lacked the precision fitting of a Mauser bolt. The trigger mechanism was functional but utilized stamped parts rather than machined components. Everything appeared to be designed for ease of manufacture rather than perfection of execution. The ammunition feeding system drew particular attention. Unlike most rifles, which used detachable box magazines, the Garand loaded from an 8-round en-bloc clip that inserted into the magazine from the top. When the last round was fired, the empty clip was automatically ejected with a distinctive metallic ping, and the bolt locked open ready for the next clip to be inserted. This system seemed needlessly complex. Why not use detachable magazines like the Gewehr 43? The en-bloc clip had to be loaded into the rifle in a specific orientation. If a soldier needed to top off a partially empty rifle, the remaining rounds had to be ejected, wasting ammunition. The automatic clip ejection made a distinctive sound that could reveal a soldier's position to the enemy. These seemed like significant tactical disadvantages. Weber noted these observations in his initial report, anticipating that field testing would reveal additional problems with the feeding system. The gas operating system utilized a long-stroke piston connected directly to the bolt carrier. When a round was fired, expanding gas tapped from a port near the muzzle drove the piston rearward, unlocking and extracting the spent case, cocking the hammer, compressing the operating spring, and chambering a fresh round on the forward stroke. This was a robust system, similar in principle to designs used in several other semi-automatic rifles. but the specific implementation showed careful engineering. The gas port size was precisely calculated to provide reliable cycling across a wide range of ammunition pressures and environmental conditions. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel, it means a lot to us. Now, back to the story. The test firing began on the morning of September 12, 1944. A standard German infantry marksmanship course had been set up at the Kummersdorf range, with targets at 100, 200, 300, and 400 meters. For comparison purposes, Weber's team would fire the Garand alongside a Karabiner 98K and a Gewehr 43, measuring accuracy, rate of fire, and reliability under identical conditions. 3 experienced German riflemen from a Wehrmacht infantry training battalion had been selected as test shooters. All 3 were combat veterans with extensive small arms experience. The initial accuracy tests at 100 meters showed the Garand to be adequately accurate, grouping within acceptable parameters for a military rifle. At 200 meters, performance remained satisfactory. The heavier American 30-06 cartridge produced slightly more recoil than the German 7.92mm round, but not enough to affect practical accuracy. At 300 and 400 meters, the Garand's accuracy was comparable to the Karabiner 98K and superior to the Gewehr 43. These results were noted without particular surprise. Accuracy was expected from any properly manufactured rifle. The rate of fire testing produced the first significant revelation. Using the Karabiner 98K, an experienced rifleman could fire approximately 15 aimed shots per minute, working the bolt rapidly between shots. This was the standard against which German infantry tactics were built. Rifle sections were organized around this rate of fire, with machine guns providing suppressive fire, while riflemen engaged targets of opportunity. The Gewehr 43, in semi-automatic operation, could fire approximately 30 aimed shots per minute in the hands of an experienced shooter. This doubled rate of fire was the primary advantage of semi-automatic operation, and the reason the Germans continued attempting to perfect reliable semi-automatic rifles, despite the technical challenges. When the first German rifleman fired the M1 Garand at the measured cadence drill, the resulting performance shocked the evaluation team. The shooter fired 48 aimed shots in 60 seconds, pausing only to reload the 8-round clips. The semi-automatic operation allowed him to maintain sight picture between shots, with only the slight disturbance of recoil before the sights settled back on target. There was no need to remove his firing hand from the grip to work a bolt, no need to break his cheek weld from the stock. The rifle remained shouldered and pointed at the target throughout the firing sequence. When allowed to fire at maximum speed without emphasis on precision, the same shooter emptied an 8-round clip in less than 4 seconds. 48 rounds could be fired in approximately 30 seconds, when reloading time was included. This was not the theoretical maximum rate of fire, but the actual achieved rate by an experienced shooter who had only minimal familiarization with the weapon. The second and third test shooters produced nearly identical results. The Garand was delivering sustained rates of fire exceeding 60 rounds per minute, double the rate achievable with the Gewehr 43 and 4 times the rate of the standard Karabiner 98K. Weber immediately understood the implications. An American rifle squad of 12 men, all armed with M1 Garands, could deliver sustained fire equivalent to a German rifle platoon of 40 men, armed with Karabiner 98Ks. The firepower advantage was not incremental, it was transformational, but sustained rate of fire meant nothing if the weapon jammed or malfunctioned under field conditions. The reliability testing began that afternoon and would continue for 3 days, deliberately subjecting the Garand to conditions designed to induce failures. The rifle was fired until the barrel was too hot to touch, then immediately immersed in cold water to simulate extreme thermal shock. It was fired after being buried in sand. It was fired after being submerged in muddy water from a nearby creek. It was fired after being frozen overnight. It was fired after being coated with dust. It was deliberately not cleaned or lubricated between these tests. The evaluation team expected the Garand to fail. Every semi-automatic rifle they had tested German and Soviet designs alike, had proven vulnerable to harsh conditions. Mud in the gas system would cause failures to cycle. Sand in the action would jam the bolt. Excessive heat would cause parts to bind. This was the fundamental weakness of semi-automatic operation, the price paid for increased rate of fire. The M1 Garand did not fail. After 3 days of deliberate abuse, firing over 800 rounds through progressively fouling conditions, the weapon experienced exactly 2 malfunctions, both caused by defective ammunition rather than weapon malfunction. In one case, a primer failed to ignite. In another, a case separation left part of the brass cartridge in the chamber. Both malfunctions were cleared within seconds, and firing resumed. The rifle that had been dismissed as crudely manufactured continued functioning under conditions that would have disabled more precisely fitted weapons. Weber's preliminary report, submitted on September 15th, noted the performance characteristics with professional restraint, but the implications were clear in every paragraph. The Americans had not simply built a semi-automatic rifle. They had built a semi-automatic rifle reliable enough to serve as standard infantry equipment under combat conditions. This represented a fundamental advance in small arms design. How had the Americans succeeded where others had struggled? The answer began to emerge as Weber's team conducted detailed technical analysis of the Garand's design and manufacture. The key was not precision. It was appropriate tolerance. German weapons engineering tradition emphasized tight tolerances and precise fitting of parts. A Mauser bolt was individually fitted to its receiver. The locking lugs were carefully lapped to ensure even bearing surfaces. This precision produced accurate, smooth-functioning weapons when properly maintained. But tight tolerances meant that any intrusion of foreign matter, any accumulation of fouling, any slight distortion from heat or cold, could bind the mechanism. The M1 Garand was designed with deliberately loose tolerances. There was visible clearance between moving parts. The bolt moved in the receiver with clearance that would have been considered sloppy by German standards. The gas piston had substantial clearance in its cylinder. These loose tolerances meant that sand, mud, or carbon fouling had room to accumulate without binding the mechanism. Debris that would jam a tightly fitted weapon simply fell away or was pushed aside by the moving parts. The manufacturing process matched this philosophy. Rather than hand-fitting each rifle, the Garand was designed so that parts were interchangeable between weapons. Any bolt would function in any receiver. Any trigger group would fit any rifle. This interchangeability meant that damaged parts could be replaced in the field, without requiring skilled armourers to fit them. It also meant that manufacturing could be distributed across multiple contractors, with different companies producing different components that all assembled into functional weapons. The stamped parts noted earlier were not evidence of corner cutting. They were evidence of design optimization for mass production. A stamped part could be produced in seconds by a power press operated by a semi-skilled worker. An equivalent machined part might require minutes of work by a skilled machinist on precision equipment. When millions of rifles needed to be manufactured, the difference between seconds and minutes per part became the difference between adequate production and insufficient supply. Weber's team calculated approximate production rates based on manufacturing methods they could deduce from examining the weapon. The Garand's design allowed production by workers with minimal training, using manufacturing equipment that did not require the precision of traditional weapons-making machinery. Many components could be produced by automotive industry suppliers with only slight modifications to existing equipment. This was mass production applied to military small arms with a thoroughness that German industry had never attempted. The examination of the rifle's stock revealed additional evidence of production optimization. The walnut stock was inlet to receive the metal components using duplicating machinery that reproduced a master pattern. The process left visible tool marks, but the fitting was accurate enough for military purposes. The stock could be manufactured by workers with basic woodworking skills, rather than requiring traditional gunstock makers. The wood-to-metal fit, while not achieving the precision of a custom sporting rifle, was entirely adequate for a combat weapon. Every aspect of the Garand's design reflected this same philosophy. Good enough for purpose, designed for reliable function rather than aesthetic perfection, optimized for manufacturing speed and ease of maintenance. German weapons represented the peak of traditional craftsmanship. The M1 Garand represented industrial design applied to infantry weapons. Neither approach was inherently superior. They reflected different answers to different questions. German design asked, how good can we make this weapon? American design asked, how do we make enough of these weapons to equip an army of millions? The interrogation of captured American soldiers provided additional context. Several dozen American prisoners of war were held at camps in Germany, and intelligence officers arranged for some to be questioned about their experience with the M1 Garand. The Americans were uniformly positive about their rifle. They reported that it functioned reliably in combat. Maintenance was simple enough that even poorly trained recruits could keep their weapons operational. The semi-automatic operation made aimed fire easier because sight alignment was not disturbed by working a bolt. The 8-round capacity was adequate for most combat situations. Most significantly, the Americans expressed complete confidence in their rifles. They believed, accurately, that their standard infantry weapon was superior to what their opponents carried. This psychological factor, the confidence that came from knowing you had better equipment than the enemy, was not quantifiable in technical evaluations, but was nonetheless significant in combat effectiveness. German soldiers armed with bolt-action rifles facing American infantry with semi-automatic rifles were at a tangible disadvantage in any firefight. The superior rate of fire translated directly into superior suppressive capability and higher hit probability. Weber's team also examined the ammunition used with the M1 Garand. The 30-06 Springfield cartridge was powerful, delivering energy comparable to German 7.92mm ammunition. But what impressed the evaluators was the manufacturing quality and consistency. The American cartridges showed precise dimensions and uniform assembly. Primers were seated evenly. Powder charges were consistent. The brass cases showed minimal dimensional variation. This manufacturing precision ensured reliable feeding and extraction, critical factors in semi-automatic rifle operation. Inconsistent ammunition dimensions, common in wartime production when quality control was sacrificed for quantity, would cause malfunctions in a semi-automatic weapon that would not affect a manually operated bolt-action rifle. The Americans had evidently maintained ammunition quality standards, despite massive production increases. By September 18th, the evaluation was complete. Weber's final report ran to 47 pages of technical analysis, performance data, and operational assessment. The conclusions were unambiguous. The M1 Garand was superior to any standard infantry rifle in service with any army in 1944. Its reliability equaled or exceeded that of bolt-action rifles, while delivering 3 to 4 times their rate of fire. The design was optimized for mass production, allowing the Americans to equip their entire infantry with a weapon that other nations could only issue selectively to elite units. The manufacturing philosophy represented a fundamental departure from traditional weapons making, prioritizing function and producibility over precision and finish. The report noted that Germany could not replicate the M1 Garand even if the design were fully available. The manufacturing infrastructure did not exist. German industry was organized around skilled craftsmen, producing relatively small numbers of precisely fitted weapons. Converting to American-style mass production would require completely rebuilding the small arms industry, training an entirely new workforce, and accepting lower standards of finish that were culturally difficult for German engineers to embrace. More fundamentally, by September 1944, Germany lacked the industrial capacity and raw materials to undertake such a transformation, even if leadership had wanted to do so. The report was distributed to Wehrmacht High Command, Waffen-SS leadership, and senior Ordnance Bureau officials. How many people read it is unknown. By autumn 1944, reports about superior Allied equipment were arriving daily from every front. The strategic situation was deteriorating rapidly. The Soviets were approaching the eastern borders of the Reich. The Western Allies had liberated France and were approaching Germany's western frontier. Industrial production was disrupted by strategic bombing. Resources were critically short. Technical evaluations of captured equipment, however accurate, could not change these realities. Weber's report on the M1 Garand joined thousands of other reports in archives, documenting capabilities that Germany could understand but not counter. The M1 Garand itself, serial number 3247819, remained at Kummersdorf as a reference specimen. Additional captured examples arrived over the following months as American and German forces continued engaging along the Western Front. Each example confirmed the findings of the initial evaluation. The rifle was reliable, effective, and represented a level of manufacturing sophistication and production capacity that Germany could not match. German soldiers encountering American infantry experienced firsthand what the evaluators at Kummersdorf had documented technically. In firefights, American squads could generate suppressive fire volumes that pinned down German units armed with bolt-action rifles. The semi-automatic fire discipline of American infantry allowed them to engage targets rapidly without exposing themselves during the vulnerable moment of working a bolt. The tactical advantage was tangible and contributed to American combat effectiveness throughout the final campaigns of the war. Some German units, particularly Waffen-SS formations and elite Wehrmacht units, were equipped with St. G44 assault rifles by late 1944. The St. G44, firing an intermediate cartridge in selective fire mode, was arguably more advanced than the M1 Garand in conceptual terms. It represented the future of infantry small arms, but production of the St. G44 never exceeded approximately 425,000 units total, compared to over 4 million M1 Garands produced during the war years. The Americans had equipped their entire infantry with semi-automatic rifles. The Germans had equipped a fraction of their forces with a technically superior but far scarcer weapon. In industrial warfare, the side that fields adequate equipment in overwhelming quantity holds decisive advantages over the side that fields superior equipment in insufficient numbers. This was the lesson of the M1 Garand, the lesson that Weber's evaluation team recognized in September 1944, and the lesson that the Wehrmacht learned through bitter experience in the final campaigns of the war. The implications of the M1 Garand evaluation rippled through German military circles in ways that extended far beyond tactical assessments of infantry combat. What Weber and his team had documented at Kummersdorf represented something more profound than a superior rifle design. It revealed a fundamental philosophical divergence in how nations approached the problem of equipping mass armies for industrial warfare. This divergence would prove as decisive as any battlefield engagement in determining the war's outcome. Lieutenant Colonel Hans-Dieter Krantz, who supervised weapons procurement for the Ordnance Bureau, received Weber's report in late September 1944. Krantz had spent his career in military logistics and industrial planning, overseeing the production and distribution of small arms to Wehrmacht units. His responsibilities included managing contracts with manufacturers, allocating scarce resources, and ensuring that frontline units received adequate weapons supplies. The Garand evaluation landed on his desk at a moment when every aspect of German military production was approaching crisis. Krantz read Weber's technical analysis with growing recognition that the document described not merely a weapon, but an entire industrial philosophy that Germany had failed to adopt. The realization was both intellectually fascinating and operationally devastating. German weapons development had always been guided by the principle that military equipment should represent the finest engineering and craftsmanship the nation could produce. This was not mere pride. It reflected a coherent theory that soldiers deserved the best tools available and that superior individual equipment could compensate for numerical disadvantages. A German soldier with a superbly crafted Mauser rifle, accurate and reliable, could theoretically defeat multiple enemies equipped with inferior weapons. This theory had proven correct in many historical contexts, but it was failing in 1944 because the Americans were not fielding inferior weapons. They were fielding different weapons, designed according to different principles, and producing them in quantities that made German production look insignificant by comparison. Krantz requested additional information from intelligence sources about American small arms production capacity. The data that arrived over the following weeks painted a picture of industrial mobilization unprecedented in military history. Springfield Armory, the primary manufacturer of the M1 Garand, had been producing the rifle since 1937. By 1941, production had reached approximately 600 rifles per day. Following American entry into the war, production accelerated dramatically. Springfield Armory expanded facilities, streamlined manufacturing processes, and increased workforce size. By 1943, daily production exceeded 1,500 rifles, but Springfield was only one source. Winchester Repeating Arms Company had been contracted to produce M1 Garands beginning in 1939, with production ramping up through 1940 and 1941. Winchester's experience in sporting rifle manufacture translated effectively to Garand production, and the company quickly achieved production rates comparable to Springfield. Harrington and Richardson Arms Company and International Harvester Company were added as contractors in 1952 and 1953 respectively, further expanding production capacity. International Harvester's involvement was particularly revealing. The company's primary business was agricultural equipment, tractors, and harvesting machinery. Their manufacturing capabilities, oriented toward mass production of mechanical devices, proved readily adaptable to rifle production. This demonstrated that Garand manufacture did not require specialized weapons-making expertise. Any company with adequate metalworking and assembly capabilities could produce the rifle, given proper tooling and training. The total M1 Garand production figures, compiled by German intelligence, were staggering. Approximately 4.5 million rifles would be manufactured between 1937 and 1945, with the vast majority produced during the war years. Peak monthly production in 1944 exceeded 100,000 rifles. The United States was producing M1 Garands at rates sufficient to equip not only its own rapidly expanding military, but also to provide rifles through Lend-Lease to Allied nations. Krantz compared these figures to German rifle production. Total carabiner, 98K production from all manufacturers throughout the war would reach approximately 14.5 million rifles, seemingly a much larger number. But the 98K was Germany's only standard infantry rifle, produced over 6 years of war by the entire German small arms industry, operating at maximum capacity. The Americans were producing 4.5 million semi-automatic rifles in addition to other weapons types, while maintaining production of submachine guns, machine guns, pistols, and other small arms at equally impressive rates. The American industrial achievement was not merely quantitative. The quality and consistency of manufacture remained high, despite massive production increases. German intelligence officers who examined multiple captured M1 Garands noted that rifles from different manufacturers and different production years were virtually identical in specifications and performance. Parts were genuinely interchangeable. A bolt from a Springfield rifle would function perfectly in a Winchester rifle. This level of standardization across multiple contractors required sophisticated quality control and manufacturing coordination that impressed even as it dismayed German observers. How had the Americans achieved this? The answer lay in manufacturing philosophy and industrial organization that differed fundamentally from German practices. American industry had pioneered mass production techniques in the automotive sector during the 1920s and 1930s. The assembly line methods developed by Henry Ford and other manufacturers emphasized interchangeable parts, specialized tooling, division of labor, and continuous workflow. These techniques had transformed automobile production, making cars affordable to millions of Americans. When applied to weapons manufacture, the same principles produced comparable results: high production volumes with consistent quality. The M1 Garand was designed from its inception with mass production in mind. John Garand, the rifle's designer, worked at Springfield Armory, where he had daily contact with manufacturing personnel. His design reflected practical understanding of what could be efficiently manufactured. Complex parts that would require extensive machining were avoided. Tolerances were specified to allow for manufacturing variation while maintaining function. The design utilized proven materials and standard manufacturing processes. This was engineering integrated with manufacturing consideration, not engineering performed in isolation and then handed to manufacturers to figure out production methods. German weapons design followed a different pattern. Engineers designed weapons to achieve maximum performance, then expected manufacturers to determine how to produce them. If a design required hand-fitting or specialized machining, that was considered a manufacturing problem, not a design problem. The result was weapons that achieved excellence in individual performance, but were difficult and time-consuming to manufacture. The cultural dimensions of this difference ran deep. German engineering tradition valued precision and craftsmanship. A master gunsmith took pride in producing rifles where every part fit perfectly, where tolerances were minimal, where the finish was impeccable. This tradition produced magnificent individual weapons but was incompatible with the demands of corporate, equipping millions of soldiers in a global war. American industrial culture valued efficiency and pragmatism. If a part could be made with a stamping press instead of a milling machine, use the stamping press. If looser tolerances produced adequate function while allowing faster manufacturing, use looser tolerances. The goal was not perfection but sufficiency, producing weapons good enough for purpose in quantities sufficient to need. Neither approach was inherently superior in abstract terms. In peacetime, with limited production requirements, the German approach produced finer individual weapons. In total war, with the need to equip millions of soldiers, the American approach proved decisively more effective. Krantz summarized these observations in a memorandum to senior Ordnance Bureau officials in October 1944. His analysis was blunt. Germany could not match American small arms production using current methods. The industrial infrastructure, workforce skills, and manufacturing philosophy were fundamentally mismatched to the requirements of mass production warfare. Converting to American-style production would require years of industrial reorganization that Germany did not have. Even if such conversion were possible, resource shortages in steel, coal, and other materials made increased production of any weapon system problematic by late 1944. The memorandum concluded that Germany's best option was to focus remaining manufacturing capacity on weapons systems, where technical superiority might compensate for numerical disadvantage, specifically advanced aircraft and armored vehicles. Small arms production should continue with existing designs and methods, accepting that German infantry would face American infantry equipped with superior rifles. There was no practical alternative. The memorandum was received with the resignation characteristic of German military planning in the war's final year. Everyone in leadership positions understood by late 1930s that Germany was losing. The question was not whether defeat could be avoided, but only how long the end could be delayed. Reports about Allied material superiority, whether concerning rifles, tanks, aircraft, or industrial production, simply added detail to a picture already clear in its essential outline. The examination of the M1 Garand at Kummersdorf became one more data point in a comprehensive understanding of Germany's strategic impossibility. Yet the significance of the Garand evaluation extended beyond its immediate military implications. The rifle represented a case study in how industrial societies mobilize for modern warfare, and how decisions made years before conflict begins can determine outcomes once fighting starts. The M1 Garand was adopted as standard U.S. infantry rifle in 1936, 5 years before American entry into World War II. The decision was controversial at the time. Semi-automatic rifles were unproven in military service. The existing Springfield, 1903, bolt-action rifle was reliable and adequate. Many military conservatives argued that infantry did not need semi-automatic fire, that such weapons would encourage soldiers to waste ammunition, that the added complexity was unjustified. The U.S. Army leadership, particularly Chief of Staff General Douglas MacArthur and later General George Marshall, made the strategic decision to adopt the Garand despite these objections. Their reasoning was that future warfare would require higher volumes of infantry fire and that semi-automatic operation, if reliable, offered decisive advantages. They accepted the risks of adopting relatively unproven technology because they believed the potential benefits justified those risks. This decision, made in peacetime when there was time to work out production problems and train troops on the new weapon, proved decisive when war came. By 1941, production was established, training protocols were developed, and the M1 Garand was proven reliable. American infantry entered World War II equipped with a weapon superior to what any other nation issued as standard equipment. Germany made different choices. The Wehrmacht entered the war with the Karabiner 98K, an excellent bolt-action rifle derived from designs dating to the 1890 seconds. German weapons designers were aware of semi-automatic rifle technology and had experimented with various designs. The Gewehr 41 was adopted in 1941, the same year America entered the war, but the German semi-automatic rifles were never refined to the point of reliability comparable to the M1 Garand, and production remained limited. The fundamental decision to retain bolt-action rifles as standard equipment was not wrong by standards of 1939. It was conservative but reasonable given the known reliability issues with semi-automatic designs. The error was in failing to anticipate how industrial warfare would evolve and what capabilities would prove decisive. The Americans had anticipated correctly, or perhaps had simply been willing to gamble on newer technology. The result was a 5-year advantage in fielding semi-automatic rifles as standard equipment. By the time German engineers examined captured Garands in 1944, that 5-year head start was insurmountable. The soldiers who carried M1 Garands into combat experienced the weapon's advantages directly and immediately. American infantryman Robert Leckie, who served in the Pacific Theater, later wrote about his Garand with something approaching affection. The rifle was reliable, he noted, functioning in the mud and humidity of Pacific islands where other weapons failed. The semi-automatic operation meant that in firefights he could focus on aiming and firing rather than on working a bolt. The 8-round capacity was adequate for most combat situations, and the automatic clip ejection, while noisy, allowed rapid reloading under stress. Other American veterans expressed similar sentiments. The M1 Garand became, in the words of General George Patton, the greatest battle implement ever devised. This was hyperbole, but it reflected genuine appreciation from soldiers whose lives depended on their weapons. The confidence that came from knowing you had reliable, effective equipment was not trivial. It affected morale, combat effectiveness, and tactical decision-making. German soldiers facing American infantry were aware they were outgunned in terms of rate of fire. This awareness affected their tactical choices and psychological state. The technical staff at Kummersdorf continued examining captured American equipment throughout late 1944 and into early 1945. Each item told a similar story. American equipment was well designed for mass production, manufactured to consistent standards, available in quantities that German industry could not approach. The pattern was consistent across weapons, vehicles, communications equipment, and supplies. The Americans had solved the industrial problems of modern warfare more thoroughly than any other nation. They had integrated design and manufacturing considerations from the beginning. They had organized production around interchangeable parts and assembly line methods. They had scaled production to meet the requirements of global conflict. Most significantly, they had started this process before the war began, giving them years of advantage in working out problems and establishing production. Germany's technical sophistication in individual weapons and equipment was undeniable. German optics, German armor metallurgy, German aeronautical engineering were in many respects more advanced than Allied equivalents. But these advantages could not compensate for the fundamental disparity in production capacity and the philosophical differences in how equipment was designed for manufacture. As winter approached in 1944, the strategic situation continued deteriorating. The Ardennes offensive in December, Germany's last major attack in the West, achieved initial surprise but ultimately failed due to insufficient resources, particularly fuel. By January 1945, Soviet forces were crossing into Germany from the east. Western Allied forces were closing on the Rhine. The Reich was being compressed from multiple directions, its industrial capacity devastated by strategic bombing, its resources exhausted by years of total war. The evaluation reports from Kummersdorf, documenting the technical superiority of captured Allied equipment, were filed away in archives. By then, everyone understood that Germany had lost the industrial war as decisively as it was losing the military war. The two were inseparable. Modern warfare was industrial warfare, and industrial capacity determined outcomes as surely as battlefield tactics. The M1 Garand that had been examined so thoroughly at Kummersdorf remained in storage as the war ground toward its conclusion. The rifle would survive the war and eventually find its way to a museum collection, one of thousands of artifacts documenting the conflict. But its historical significance extended beyond its physical existence. It represented a moment when German engineers confronted clear evidence of American industrial superiority and recognized the implications for the war's outcome. The manufacturing philosophy embodied in the M1 Garand, designed for mass production rather than perfection, interchangeable parts rather than hand-fitting, adequate quality in overwhelming quantity rather than excellent quality in limited quantity, would become standard practice in post-war industrial production. The lessons learned in wartime weapons manufacture transferred to civilian manufacturing in the post-war era. The integration of design and manufacturing consideration became recognized as essential engineering practice. The Germans who examined the Garand in 1944 were documenting principles that would reshape industrial production globally in the decades that followed. Today, the M1 Garand is recognized as one of the outstanding rifle designs of the 20th century. Its combination of reliability, effectiveness, and manufacturability set standards that influenced subsequent weapons development. Modern military rifles, whether the American M16, the Soviet AK-47, or current assault rifles, reflect design principles pioneered or refined in the Garand's development. The weapon served U.S. forces through World War II and the Korean War, remaining in frontline service until replaced by the M14 in the late 1952. Even after its retirement from military service, the M1 Garand remained in production for civilian sale, with thousands manufactured for rifle enthusiasts and competition shooters. The rifle's design has proven so sound that Garands manufactured in the 1940 seconds remain functional and accurate today, more than 80 years after their production. This longevity testifies to the quality of materials, the robustness of design, and the adequacy of manufacture that German engineers documented in their 1944 evaluation. The story preserved in Weber's report and Kranz's memoranda reveals the moment when Germany's technical staff understood the full implications of American industrial mobilization. They were not examining just a rifle. They were examining evidence of an industrial system that had solved the problems of modern warfare more comprehensively than Germany had managed. The recognition was clear, documented, and ultimately futile. Understanding that your opponent possesses decisive advantages does not provide the means to counter those advantages when they are rooted in fundamental disparities of resources and industrial organization. The examination of the M1 Garand at Kummersdorf in September 1944 stands as a testament to professional military analysis conducted even as strategic defeat loomed. Weber and his team documented what they found with precision and honesty, producing analysis that was technically accurate, even though it could not influence the war's outcome. Their work provides historians with detailed contemporary German assessment of American capabilities, insights into how the Wehrmacht understood the forces arrayed against it, and evidence of the intellectual honesty that characterized German technical evaluation, even in desperate circumstances. The M1 Garand represented more than mechanical advantage. It symbolized the industrial transformation of warfare and the decisive importance of production capacity in modern conflict. The rifle's creation required foresight to adopt unproven technology, engineering skill to design for manufacturability, industrial capability to produce at scale, and organizational competence to coordinate multiple manufacturers producing to identical standards. Each of these elements was necessary. Together they produced a weapon system that gave American infantry tangible advantages in every engagement. When German soldiers encountered American infantry in the forests of the Ardennes, on the approaches to the Rhine, or in the final desperate defense of German cities, they faced opponents armed with semi-automatic rifles that could deliver 3 to 4 times the rate of aimed fire that German bolt-action rifles could achieve. This advantage, multiplied across thousands of engagements, contributed meaningfully to Allied victory. It was not the sole decisive factor. Wars are decided by combinations of strategy, tactics, logistics, industrial capacity, leadership, and countless other elements. But the M1 Garand was one of those elements, and its contribution was significant. The engineers at Kummersdorf, who examined the captured rifle in September 1944, understood all of this. Their reports documented not just specifications and performance data, but the recognition that Germany faced an opponent whose industrial system had proven more adaptable to the demands of modern warfare. This recognition, reached through careful technical analysis rather than battlefield experience, provided clear-eyed assessment of strategic realities that senior leadership often failed to acknowledge. The legacy of the M1 Garand extends beyond its military service. The rifle demonstrated that well-designed equipment, manufactured to consistent standards in sufficient quantities, provides decisive advantages in industrial conflict. This lesson, learned at tremendous cost by those who faced American infantry armed with Garands, influenced post-war military procurement and industrial planning. The integration of manufacturing consideration into design processes, the emphasis on interchangeable parts and standardization, the recognition that adequate equipment in quantity often proves more valuable than superior equipment in limited numbers. All these principles were reinforced by the Garand's success. Today, when historians examine the factors that determined World War II's outcome, industrial production capacity features prominently in every serious analysis. The side that could build more weapons, more ammunition, more vehicles, more aircraft, and more supplies faster than they were consumed in combat, held advantages that battlefield skill alone could not overcome. The M1 Garand exemplified this reality in tangible form, a weapon that combined good design with superior manufacturing to provide American infantry with equipment advantages that contributed directly to Allied victory. The rifle that German engineers examined at Kummersdorf told a story larger than its technical specifications. It revealed the nature of industrial warfare and the importance of decisions made years before conflicts begin, when nations choose how to organize their industries, what manufacturing philosophies to adopt, and what capabilities to develop. Those choices, made in peacetime by leaders who may never see combat, determine what resources are available when war comes. The M1 Garand was one result of wise choices made by American leadership in the 1930 seconds. The superiority German engineers documented in 1944 was created by decisions made a decade earlier, when the United States Army chose to adopt semi-automatic rifle technology despite its risks and uncertainties. That choice, vindicated by the rifle's performance in global conflict, stands as example of strategic foresight, translating into tactical advantage. The war ended in May 1945 with Germany's unconditional surrender. The rifle examined at Kummersdorf survived, eventually becoming a museum piece. But the lessons it taught, documented carefully by German engineers who understood they were recording not just technical data but evidence of their nation's strategic defeat, remain relevant to anyone seeking to understand how modern conflicts are decided. The post-war years brought unexpected chapters to the story of the M1 Garand and the men who had studied it. Friedrich Weber, the ordnance officer who had directed the Kummersdorf evaluation, survived the war and found himself in American custody in June 1945. His technical expertise and detailed knowledge of German weapons development made him valuable to Allied intelligence services, seeking to understand the full scope of German military technology. Weber was interrogated extensively, not harshly but thoroughly, by American technical intelligence officers who wanted to understand German perspectives on Allied equipment. During one of these sessions in August 1945, Weber was shown a copy of his own report on the M1 Garand. The American officer conducting the interview asked whether Weber stood by his conclusions. Weber's response, preserved in the interrogation records, was straightforward. The M1 Garand was superior to German standard infantry rifles in every practical measure except perhaps accuracy at extreme ranges, and even that advantage was marginal. The rifle's reliability under field conditions exceeded what German engineers had believed possible for semi-automatic weapons. Most significantly, the manufacturing philosophy the Garand represented, design integrated with production consideration from the beginning, was something German industry had never fully embraced despite possessing the technical capability to do so. The American officer asked why Germany had not developed comparable weapons if the technical capability existed. Weber's answer revealed much about the cultural and institutional barriers that had limited German industrial adaptation. German engineering culture, he explained, valued precision and craftsmanship above efficiency. This was not mere stubbornness, but reflected deeply held beliefs about how quality products should be made. A German engineer took professional pride in specifying tight tolerances and demanding excellent finish. To deliberately design with loose tolerances and accept visible tool marks felt like abandoning standards, like admitting defeat before beginning. This cultural barrier was reinforced by institutional structures. Weapons design was performed by engineers who had limited contact with manufacturing personnel. Design specifications were handed to manufacturers who were expected to achieve them regardless of production difficulty. If manufacture was complex and time-consuming, that was considered a manufacturing problem, not a design problem. The integration of design and manufacturing consideration that characterized American industry required organizational structures that German industry lacked. Weber's observations were not offered as excuses, but as analysis. He was attempting to explain, for his own understanding as much as for his interrogators, how Germany had failed to adapt to industrial warfare despite possessing world-class engineering talent and significant manufacturing capacity. Other German technical personnel provided similar insights during post-war interrogations. Hans-Dieter Krantz, the logistics officer who had written the memorandum on Garand, production implications, was interviewed by American industrial analysts in September 1945. Krantz provided detailed information about German weapons production capacity, manufacturing methods, and resource allocation. His assessment was that Germany had never truly mobilized for total war in the industrial sense until far too late. Weapons production increased significantly after 1942, but the fundamental organization of industry remained oriented toward peacetime methods. Skilled craftsmen producing limited quantities of high-quality goods, small workshops and factories maintaining traditional methods, resistance to standardization and mass production techniques that were seen as threatening to quality and craftsmanship. By the time German leadership recognized the necessity of total industrial mobilization, the strategic situation had deteriorated to the point where effective reorganization was impossible. Allied bombing disrupted production. Resource shortages limited what could be manufactured regardless of industrial organization. The trained workforce was depleted by military conscription. The opportunity to build an industrial system optimized for wartime production had existed in the late 1930s, but had not been seized. The Americans had seized that opportunity, and the results were visible in weapons like the M1 Garand. American interrogators found these German assessments valuable for understanding both German capabilities and American advantages. The technical evaluations produced by German engineers provided independent confirmation of American equipment performance. When German experts stated that the M1 Garand was superior to German rifles, this carried weight precisely because it came from adversaries who had every incentive to minimize Allied advantages. The interrogation records were compiled into comprehensive reports on German weapons development and production that informed American post-war military planning. One unexpected outcome of the interrogations was the employment of several German engineers by American companies in the post-war years. Friedrich Weber immigrated to the United States in 1947, sponsored by an American firearms manufacturer that valued his expertise in weapons testing and evaluation. He spent the remainder of his career working on sporting rifle development, applying the analytical skills he had honed evaluating military weapons to improving civilian firearms. In interviews conducted years later, Weber reflected on the irony that he had spent the war studying American weapons to help defeat the United States, then spent the peace working for American companies, applying lessons learned from that study. The experience had taught him, he said, that the best engineering was not the most sophisticated but the most appropriate to purpose. A weapon that was adequate and reliable and manufacturable in quantity served its purpose better than a masterpiece that could not be produced in sufficient numbers. The M1 Garand itself continued its service life long after the war ended. American forces carried Garands into Korea in 1950, and the rifle proved as effective in that conflict as it had in World War II. The weapon's reliability in harsh conditions, its semi-automatic rate of fire, and its powerful .30-06 cartridge made it well suited to the varied terrain and combat conditions of the Korean peninsula. Chinese forces, initially equipped with a mixture of Japanese rifles from World War II, Soviet bolt-action rifles, and some semi-automatic weapons, found themselves outgunned in infantry engagements with American units. The rate of fire advantage that had given American infantry superiority over German forces in Europe provided similar advantages against Chinese infantry in Korea. By the late 1952s, military rifle development had moved toward lighter cartridges and fully automatic capability, exemplified by weapons like the M14 and eventually the M16. The M1 Garand was gradually phased out of frontline American service, though it remained in use with reserve units and allied nations for years afterward. Many Garands were provided through military assistance programs to nations aligned with the United States during the Cold War. The rifle served with dozens of countries' militaries, a testament to its versatility and reliability. Greece, Turkey, South Korea, the Philippines, and numerous other nations equipped their forces with American-supplied M1 Garands, and many of these rifles remained in service into the 1972nd and beyond. The manufacturing lessons learned in Garand production influenced post-war industrial development in ways that extended far beyond weapons manufacture. The principles of designing for manufacturability, standardizing components for interchangeability, organizing production around assembly line methods, and integrating design and manufacturing consideration from project inception became standard practice in multiple industries. American automotive manufacturers, electronics companies, and consumer goods producers all applied these principles in the post-war economic boom. Japanese industry, rebuilding after wartime devastation, studied American manufacturing methods extensively and adapted them with characteristic thoroughness. The result was Japanese economic resurgence, built on manufacturing efficiency and quality control, that eventually challenged American industrial dominance. The irony was not lost on observers, who noted that lessons learned in American wartime production were being applied by former adversaries to compete with American companies in peacetime markets. German industry, rebuilding under Allied occupation, also absorbed these lessons. The post-war German economic miracle was built partly on applying mass production techniques to industries that had previously relied on craft production methods. German automotive manufacturers like Volkswagen exemplified this transformation, producing reliable vehicles in enormous quantities, using methods that would have been foreign to pre-war German industrial culture. The Volkswagen Beetle, designed for mass production and manufactured in numbers exceeding 20 million units over its production life, represented a German embrace of the manufacturing philosophy that the M1 Garand had exemplified 2 decades earlier. The veterans who had carried M1 Garands in combat maintained strong affection for their rifles in post-war years. Veterans' organizations and historical societies preserved Garands as artifacts of their service. Many veterans purchased surplus Garands when they became available through the civilian marksmanship program, wanting to own the rifles they had carried in war. The distinctive weight and balance, the solid feel of the walnut stock, the mechanical clack of the action cycling, these sensory memories remained powerful decades after combat service ended. Rifle ranges across America hosted competitions where veterans and enthusiasts fired M1 Garands at targets, maintaining skills and honoring traditions. The rifle's accuracy made it well suited to competitive shooting, and Garand matches became popular events in shooting sports communities. Modern competitors firing Garands manufactured 70 or 80 years ago consistently achieve impressive accuracy, demonstrating that the rifles remain mechanically sound despite their age. This longevity speaks to the quality of materials and manufacture that German evaluators had documented in 1944, even as they noted the deliberate avoidance of unnecessary refinement. The Garand was built to last because durability served military purposes, not because aesthetic perfection was valued for its own sake. That pragmatic approach to engineering produced rifles that continued functioning generations after their manufacture. Museums around the world preserve M1 Garands in their military history collections. The Smithsonian Institution, the National World War II Museum, the Imperial War Museum, and countless smaller institutions display Garands alongside the stories of the men who carried them. These exhibits typically include technical specifications, historical context about the rifle's development and service, and often personal accounts from veterans who used the weapon in combat. Some exhibits display the rifle alongside German weapons like the Karabiner 98K and Gewehr 43, allowing visitors to compare the different approaches to infantry armament. These comparative displays effectively illustrate the points that German evaluators made in 1944. The physical differences between the weapons, the contrasts in manufacturing philosophy, and the implications for combat effectiveness become tangible when the actual hardware is examined side by side. Educational programs at these museums use the M1 Garand as a teaching tool for explaining industrial warfare and the importance of manufacturing capacity in modern conflicts. Students learning about World War II can understand abstract concepts like industrial mobilization more concretely when shown physical examples of how manufacturing philosophy influenced military equipment. The rifle becomes more than an artifact. It becomes a lens through which to understand larger historical forces. The technical documentation produced by German evaluators at Kummersdorf has proven valuable to historians and researchers studying wartime weapons development. Weber's report, preserved in captured German archives, provides detailed contemporary assessment of American rifle technology as understood by adversaries. Researchers studying the M1 Garand's development and service can compare American documentation with German analysis, gaining perspective on how the weapon was perceived by both users and opponents. This comparative analysis reveals that German technical understanding was accurate. The evaluators at Kummersdorf correctly identified the Garand's strengths and understood the implications for infantry combat. What they could not change was the strategic context. Understanding that your opponent possesses superior equipment does not provide the means to counter that superiority when the advantages are rooted in decisions made years earlier and industrial capabilities that cannot be quickly replicated. The historical lesson is not that Germany failed to understand American capabilities, but that understanding capabilities is insufficient when you cannot match them. Modern military planners studying the Pacific theater of World War II have drawn similar lessons from Japanese experiences facing American industrial might. Japanese forces, technologically sophisticated and tactically skilled, found themselves progressively overwhelmed by American material advantages. Japanese weapons were often excellent in individual quality, but insufficient in quantity. Japanese industry, while advanced, could not match American production rates. The pattern was strikingly similar to Germany's experience in Europe, and the outcomes were equally decisive. Contemporary discussions of military preparedness and defense industrial base capacity frequently reference World War II examples, including the M1 Garand story, to illustrate the importance of maintaining production capability even in peacetime. The ability to rapidly expand production when conflict begins, to design weapons with manufacturability in mind, and to organize industrial resources for wartime needs are recognized as critical elements of national defense. These capabilities cannot be created quickly when war begins. They must be developed in advance, maintained during peace, and ready to scale when needed. The United States military's current emphasis on defense industrial base resilience reflects lessons learned from World War II about the decisive importance of production capacity. Modern conflicts may not require the mass production of rifles that World War II demanded, but the underlying principle remains valid. The side that can produce, maintain, and sustain advanced weapons systems possesses advantages that tactical skill alone cannot overcome. The M1 Garand's legacy thus extends into contemporary strategic thinking, serving as historical example of how industrial capability shapes military effectiveness. The rifle that German engineers examined in 1944 continues teaching lessons 80 years later, not about rifle design specifically, but about the relationship between industrial organization and military capability. The human stories embedded in this history add depth to the technical and strategic narratives. The young American soldiers who carried M1 Garands into combat, many of them drafted civilians with minimal military training, found confidence in their weapons' reliability and effectiveness. Letters, home and memoirs written decades later frequently mention the rifle with appreciation and even affection. The weapon worked when needed, gave them fighting a chance in desperate situations, and contributed to their survival. For these men, the M1 Garand was not an industrial product or a strategic asset, but a tool that might mean the difference between life and death. The German soldiers who faced American infantry armed with Garands had different perspectives. Many German veterans, in post-war interviews and memoirs, acknowledged the firepower disadvantage they faced in combat against American units. The semi-automatic fire from American positions could suppress German infantry armed with bolt-action rifles, limiting their ability to maneuver or return effective fire. Some German veterans expressed frustration that their army, which they considered technically sophisticated, had not equipped them with comparable weapons. Others accepted it as another manifestation of the material superiority that Allied forces possessed across all categories of equipment. For German veterans, the American rifle represented the overwhelming resources arrayed against them, resources that no amount of courage or tactical skill could overcome. The engineers and technical staff who evaluated captured equipment occupied a unique position in this history. They were neither frontline combatants experiencing weapons in life-or-death situations, nor strategic leaders making policy decisions about force structure and equipment procurement. They were technical professionals attempting to understand opposing capabilities through systematic analysis. Their work provides historical record of how adversaries assessed each other's equipment with professional objectivity, even as the war decided their nation's fates. Friedrich Weber's career arc, from German ordnance officer evaluating enemy weapons to American immigrant working in civilian firearms industry, illustrates the complex human dimensions of technical work in wartime. Weber was not making moral choices about which side deserved victory. He was applying engineering expertise to understand weapons performance. That this expertise later proved valuable to former adversaries suggests that technical knowledge transcends national boundaries and political contexts. Engineers solving practical problems have more in common with each other across national lines than they have differences dividing them. The post-war collaboration between former German technical personnel and American companies demonstrated this professional affinity, overcoming wartime enmity. The M1 Garand's place in firearms history is secure, not because it was the most advanced rifle design of its era, but because it was the right design at the right time, adopted by a nation with the industrial capacity to produce it in quantity, and the military foresight to standardize it before war began. These factors, timing, appropriateness of design, industrial capability, and strategic foresight, combined to create a weapon system that provided tangible advantages to the nation that fielded it. The rifle succeeded not through revolutionary innovation, but through evolutionary refinement of existing technology applied with superior execution. This is often how decisive advantages emerge in military competition, not through breakthroughs that render existing capabilities obsolete, but through incremental improvements in design, manufacturing, and implementation that accumulate into significant superiority. The lesson for military planners and national leaders is that patient development of appropriate capabilities, sustained investment in industrial capacity, and willingness to adopt new technologies before their value is proven in combat can yield decisive advantages when conflict comes. The United States made these investments in the 1930 seconds and reaped the benefits throughout World War II and beyond. Other nations, facing different circumstances and making different choices, achieved different outcomes. The M1 Garand stands as one example among many of how these choices manifest in concrete military capabilities. Today, when historians compile lists of the most influential military weapons of the 20th century, the M1 Garand appears consistently near the top. Its influence extended beyond its own service life to shape subsequent rifle development and demonstrate principles of industrial design that transformed manufacturing across multiple sectors. The rifle that German engineers examined in September 1944, attempting to understand how American infantry had achieved such firepower superiority, proved to be more than just an effective weapon. It was a symbol of industrial transformation, a product of strategic foresight, and a tool that gave hundreds of thousands of soldiers enhanced capability in combat. The story of its development, production, service, and the reaction it provoked from adversaries who recognized its significance provides insights into how modern conflicts are shaped by industrial capacity and manufacturing philosophy as much as by battlefield tactics and strategic vision. The examination at Kummersdorf, documented carefully by professional engineers performing their duties even as their nation faced defeat, preserved for history a moment when the implications of industrial disparity became undeniably clear to those tasked with understanding enemy capabilities. Their honest assessment, filed away in archives and later studied by historians, serves as testament to the professional integrity that characterized much German technical work, even in desperate circumstances. The M1 Garand they studied has long since passed from military service into history, but the lessons it taught about the nature of industrial warfare remain relevant to anyone seeking to understand how nations mobilize for conflict and how technical decisions made in peacetime shape outcomes when war comes. This is the enduring legacy of a rifle that German engineers admitted, with professional honesty, represented capabilities their own nation could not match. Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.